Hello, we're going to try to squish 103, 104, and 105 on one video. Let's do it. I like this question. It says, 2 measures were taken on 18 subjects. The first 2 regression, 1 yielded this, y hat equal a plus bx. So let's write that down. Y hat equals a plus bx. So this is 2 quantitative variables. So, because does knowing what x is help me predict y? So looking at this is not the x and y. These are my residuals. So what that means is that this was graphed like this. It looks like a positive slope of 16. It looks like it touches the graph at 24. So this is 24 and it's a high slope, steep, right? So it looks something like that. And it appears there were only 18 dots along here, and somehow when we zoomed in on this line and turned it sideways, that's what this is. This graph is somebody zoomed in and turned it sideways. So I could actually kind of recreate this over here. It looks like these 18 dots, it looks like these 18 dots, when I zoom in, make a frown. And so the first thing I think of, and I always take these notes, so I'd ask that you jot this down. When I see a frown on question 103, a linear relationship is not appropriate. That's what I think of immediately. When I see a frown, a linear relationship is not appropriate. So now we must keep moving. What would be appropriate? So it looks as if the second regression, they went ahead and did log of y and log of x and produce this residual plot. So here I'm thinking I don't see a frown, I don't see a smile, although it doesn't look great. It looks a little gappy. I mean, I probably, a little bit of gap, but it's way better than this. And so your job in the residual plot is to decide, is there a pattern? If you see a pattern, you got problems. Okay, so you know linear is not appropriate. So if I look at log x versus log y in a graph, I notice it's less of a pattern. So I'm definitely looking at which one feels the best fit. I can't pick this. I can't pick that. I definitely know it's not a negative correlation because the slope is positive. Okay, so I'm relegated to the bottom 2 based on what we talked about. We've rejected regression plot 1. So therefore, our best answer is E. Let's scoot to the next question. 104. Now it says the analysis of a random sample of 500 households in a large city indicated a 98% confidence interval for a family between this amount. So there's the confidence interval that was created. They did the work for us. We're just trying to decide, well, what does that really tell us? So could this information also be used to conduct a null hypothesis? Can we do a test using the null of 40,000 against an alternative hypothesis of something other than 40,000 at an alpha of 0.02? And so this is getting to the question of, is this 98% CI similar to, is the 98% confidence interval similar to doing a significance test at an alpha of 0.02? And the answer to that question is yes, absolutely. But you got to be careful about the wording. So let's take a look. It says, no, because we don't know that. This is just not true. If we don't know that, we use the standard deviation from the sample. And we just keep on cruising. But this was to try to get us to think about Z versus T. Okay? So and then they said, no, it's not known whether the data is normal. Again, that's not important as long as you test enough people, and it looks like we're testing 500, so I don't like B. C, no, the entire data set is needed. That's not true. We've never heard anything like that. So we're down to yes. We're thinking, yeah, this you totally could. So, but what would be the outcome? So if mu was the accepted truth of 40,000, notice it's not in the interval. Well, that means something because you did a 98% confidence interval, which means we are 98% confident that the interval from 41K to 58K captures the true mean. And if the true mean is that, it's not being captured. So since 40,000 is not contained in this confidence interval, we must walk through door number 2. The null hypothesis would be rejected. So D can be the only answer because yes, in fact, we are rejecting because 40 is not contained in the interval. 40K is not contained in the interval. Okay, next question. 105, the population mean 2, 3, 5, and 7 has a mean of 4.25 and a standard deviation of 1.92. When I'm sampling with replacement, there are 16 different possible ordered sample size 2 that can be selected from this population. Okay, so I have a population, which is kind of weird. It's only 4 numbers. And if I take a sample size of 2, then can I select that from the population? The mean of each of these 16 samples is computed. So thinking about this, the mean, if you take one amount, is 4.245. And then if you take a second one, just like they gave us the example here, if you took a second one, it's the same thing. You're approximating to get that same number. So I believe that if you select 2 samples and you average them together, again, you're still expecting to get this value. So I'm locking into A, B, or C because if I take 2 numbers, and I think everything theoretically in class aligns with this, if I know the average of my population is 4.25, if I take some samples, I'm still expecting to have that same average, 4.25. Now they're trying to say, what would be the standard deviation of the sample? So this is a formula. This would just be sigma over the square root of n. And so in this example, we actually know what n is, and we know the standard deviation, 1.92. So that's what's weird about this problem. Normally we're not given that. Here we are. So we put the square root of 2, and we do a little bit of math. When I take this number and I divide by the square root of 2, I get 1.3576, which is in fact less than 92. So as we increase n, we also know as we increase n, the standard deviation gets smaller. That's one of our biggest things that we always got to remember. As we increase in, our standard deviation gets smaller. Okay, so we are locking into C, which is our answer. Thank you for joining us.